For me, the thing I find most exciting is problem solving.
We do love problems. I guess as an engineer, we really like problems. We like to have something that's difficult.
I enjoy coming to work because problems are fun.
Engineering would be great if everything was perfect, but when you're doing things for the first time or applying things a new way, stuff comes out of the woodwork and surprises you. But working with a great team of people, the ideas come and you start digging into trying to fully understand the problem and then all work together to resolve it. And often you learn far more through solving a problem than when things go smoothly. When customers come to us who've experienced problems with other engine suppliers, we know all the science behind it and we're able to explain why they hit problems, what countermeasures can be made, and help to protect their products going forward to be able to operate in the very worst climatic conditions.
We start with the customer and we listen to exactly what they need out of our products. And then really our approach here is to take that and through a series of time-tested processes, turn that into requirements that we then develop the product against and prove that it meets in every condition, in every aspect, before we then put it in production.
We do all the concepting work with the customers. We go through to make sure we understand both the altitude requirement, the ambient temperature requirements, what the customers need for load response, all those kind of things. Once we get all that defined, then we'll walk into the design space where we start specifying an engine specifically that will meet all those requirements.
Once we've gathered that information and we've characterized those interactions, then that's fed into our technical objectives document, which is a very large database of objectives for the entire engine system, and they set targets for component designers, for system designers that they have to go and achieve so that we can meet our customer requirements.
There are process partners that we've selected through the development of this program to, as we're designing the engine, to then put in front of the customer, test it. What do you think about this? Is this really what you're asking for? Does this work for you? How can we change it, make it better? So it's a very collaborative process with those process partners.
So as we initially begin to lay out engine designs and look at how we are going to configure the engine, one of the things that we do are virtual engine installations into literally hundreds of different types of machines. Every machine is a bit different. Every machine has slightly different needs. And what we look to ensure is that we can offer a product that's going to meet those needs across a range of engines.
With the diverse range of applications that our products go into, that we really understand a lot of those applications and understanding the risks associated with the different ways you can run the engines, how that can implicate how we calibrate them so that we get good in-use emissions, but also massive reliability, considering uptime, productivity, all of those things that are really, really important. We put a lot of focus on in our development programs, and we look at that through some of the concept simulation tools through to the getting prototype engines in the iron.
We have quite rigorous processes that allow us to develop those designs, have very in-depth analysis capability, so that even before we cut metal, we have a good level of confidence the design's going to work and deliver what we want.
So we're always looking to incorporate new technologies and new ways of doing things to improve how we develop the product here at Perkins. One example of that would be 3D printing.
From our designs to actually touch and feel what that component or that part might look like. And the benefit of that really was so that we could fast track all the other downstream processes before the engine had actually been built.
Every one of the first engines that we develop is hand built by a set of master technicians. Those engines are measured in hundreds of different ways as we put them together. We measure everything from the minute details of the combustion geometry in the pistons and the piston bowls themselves, to how the valves, the camshafts, all the moving parts of the engine work together. All of that is completely blueprinted. So as we put those very first engines together, we know exactly what performance specification they're built to. And that's very important to us as we look at the results when we start to actually test and develop these products. Knowing the pedigree, knowing exactly what that engine was when it started life is absolutely critical to making sure that we know how it ends life when its validation is complete.
I like the creativity of design. So being a design architect, right at the start of the program, when you're laying down ideas, and then 2 years down the line, you see the design engineers have turned those concepts into reality. You see it in the factory on the production line later on, and all of that, that's very rewarding to see.
It's very satisfying to see something that you designed, that you had in your head, designed in CAD, you simulated, you analyzed, you tested, you put it together, you made it, and to be able to touch it and run it and see how it performed. It's very satisfying.
Another way that we think about the job we do here is that in some ways we actually play the role of the first customer, the customer before the real customer. And part of our job is to make sure that the engines that we put out of development are good enough that we would buy them ourselves, that they're good enough that we would recommend them to our father, to our brother, to our mother, if their businesses were dependent on this product. So in a lot of ways, the way we think about that is thinking about ourselves as the first customer, and is the engine good enough?